Next we have Reed's Undergraduate Algebraic Geometry. It does things like playing with plane curves, category of affine varieties, and some applications to lines on cubic surface, tangent space, projective varieties. It's a very short book, so it has a lot of algebraic geometry, a very short book. It's very nice, it's well written, but there are better books out there. Cox is a much better book, but also a much thicker book, I guess. There's better books than this one out there. So I would not recommend this one, even though it's not bad at all. Here we see is Geometry Revisited, the very famous book by Coxeter and Kreutzer. So we have points and lines connected with a triangle, some properties of circles, collinearity and concurrence, transformations, introduction to inversive geometry, introduction of projective geometry. So it's a very old style book on very old style geometry. I'm still very interested in geometry, so a book like this for me is a must-have. It's very Euclidean. Barely any algebra in here. Here's one of my favorite books, A Course on Metric Geometry by Burago and Ivanov. So we see here it has metric spaces, it has length spaces, which is a generalization of metric spaces. We have constructions, spaces of bounded curvature, smooth length structures, curvature of Riemannian metrics, spaces of metric spaces, large-scale geometry, space of curvature bounded above, space of curvature bounded below. This is a very hard book. It's definitely not in a bedtime reading book, but I think it covers kind of spaces that I am very interested in. So I was interested in this because I was interested in how the Riemannian metric basically leads to a metric space, and this basically generalizes this. Like, I guess I didn't understand what a Riemannian metric was. I understand it now because I know physics, and physics explains it very well. Physics books explain very well what a Riemannian metric is, but I didn't really understand it back then, so I bought this book to really try to understand it from a mathematical point of view. This did not work out. Here we have one of my favorite all-time books, The Universe of Conics. From the ancient Greek to 21st century development. Very, very beautiful book on conics. It's brilliant. It's absolutely brilliant. So it has Euclidean plane, differential geometry, Euclidean tree space, projective geometry, projective conics, polarities and pencils, affine geometry, special problems, and other geometries. So this is beautiful, beautiful book. I love this. This is, oh my god, yeah. This is I think one. I mean, I guess not many people are interested in conics nowadays anymore, beyond just using them. But the intrinsic theory is kind of lost on us. But I wish people would be interested in this because this book is so beautiful, and yeah, this is such a beautiful, beautiful, beautiful little book. Amazing. Here we see a statistics book, Regression and Other Stories by Gelman, Hill, and Vettari. So it's a book by Gelman, which always has a bit of a weird writing style in my opinion. So it's overview, data and measurement, some basic methods in mathematics and probability, statistical inference. It has simulation, background on regression modeling, linear regression with a single predictor, fitting regression models, prediction and Bayesian inference, linear regression with multiple predictors, assumptions, diagnostics, and model evaluation, transformation and regression, logistic regression, working with logistic regression. It has other generalized linear models, design and sample size decisions, post-stratification and missing data imputation, causal inference and randomized experiments, causal inference using regression on the treatment variable, observational studies with all confounders assumed to be measured, additional topics in the causal inference, advanced regression, and multi-level models. So this is really a book on Not a, it's a book on regression, obviously, but not on the theory. Basically, how to do regression in practice, how actual problems would look like, and how you would deal with actual problems in regression. It's a book written by a real expert in data analysis on how to do data analysis. It doesn't have too much math, it doesn't have too much proofs, but it's really a book on how to. Also, how to do it in R. Highly recommended, of course. Here we see Geometry by its History by Osterman and Wanne, which is basically a book on the history of geometry. Thales and Pythagoras, Elements of Euclid. We have conic sections. There's further results in Euclidean geometry, trigonometry, Descartes' geometry, Cartesian coordinates, to be constructible or not to be constructible, spatial geometry and vector algebra, matrices and linear mappings, projective geometry. So this is a history book, of course, and it deals with the history of geometry. If you're interested in history, this is definitely a book you want to read. This is a beautiful little book. Amazing history on geometry and only on geometry. So it starts and it goes through every single one of the major evolutions in geometry and what it eventually led to, all the way to modern stuff, Cartesian geometry, and constructibility. Here is a Path Through Geometry, Groups by Byrne. So it has functions, starts very easy with functions, permutation on a finite set, groups of permutations on R and C, the Möbius group. You see stuff like the regular solids, abstract groups, inversions of the Möbius plane and stereographic projection, equivalence relations, cosets, direct products, fields and vector spaces, linear transformations, the general linear group, the vector space, eigenvectors and eigenvalues, homeomorphisms, conjugation, linear fractional groups, quaternions and rotations, affine groups, orthogonal groups, discrete groups fixing a line, and the wallpaper group. So this is a link between groups and geometry. There's no theory here. It really develops the theory with questions and only questions. So there's a lot of questions here. Barely any theorems or everything you need to prove yourself, basically. So yeah, it's very fun to go through. It's very easy to go through. So if you're like, don't want to think too much but still want to do math, this is a highly recommended book. Next with one of my thickest books. Here we have a brick, Thorne and Blandford, Modern Classical Physics. So yeah, this is about classical physics from a modern point of view. So it has it's Newtonian physics, the geometric viewpoint on Newtonian physics. Then you have special relativity, the geometric viewpoint, statistical physics, kinetic theory. It has statistical mechanics. It has statistical thermodynamics. We have random processes. We have optics, geometric optics, diffraction, interference and coherence. We have nonlinear optics. We have elasticity, elastostatics, elastodynamics. We have fluid dynamics, foundational fluid dynamics. We have vorticity, turbulence. It has waves. It has compressible and supersonic flow, convection, magnetohydrodynamics, plasma physics, the particle kinetics of plasma, waves in cold plasmas, the two-fluid formalism, kinetic theory of warm plasmas, nonlinear dynamics of plasmas, then general relativity for special to general relativity, fundamental concepts of general relativity, relativistic stars and black holes, gravitational waves and experimental tests of general relativity, cosmology. Yeah, so it's 1,400 pages long, and it has basically everything of classical physics. If you want one book which contains everything, then this is the book you want. But honestly, on every single one of these topics, there's better books out there. There's better books on general relativity. There's better books on Newtonian physics. There's better books on fluid dynamics. Yeah, I think it's a good book. It's a good attempt, but it's not a book I would recommend, basically.